Measurement of resistance. Objectives: to find the resistance of an unknown resistor from the graph of the current against the potential difference across it. Safety: if too large current is used, then the wires can get hot, which causes burns. Apparatus: power supply, switch, 5 ohm resistor, ammeter, voltmeter, rheostat, connecting wire. This ammeter has 3 scales actually. 50 milliampere here, this is 50 milliampere up, and 500 milliampere if we use that terminal, or 5 ampere down. So let us check which one is possible for our experiment. The voltmeter has 3 terminals: 300 millivolt, 3 volt, 30 volt. Rheostat has 3 terminals. If we use the 2 terminals down, the value of resistance will be fixed, 100 ohm. So to use the rheostat as the variable resistor, we have to use this terminal and that one. Also, don't use this one and this one because it has a fixed value also. So to get different values of resistance, so different values of current, we have to use this terminal and this terminal. We started to connect the circuit as shown in the diagram. Start from the positive. Of course, it is here. We adjust the power supply to 6 volt. We start from the positive terminal to the ammeter. Let us check this terminal here. It's 500 milliampere. It means this 100, 200, 300, and so on. I will use 500 milliampere. Then from the ammeter to the resistance, 5 ohm resistor, 5 ohm resistor, and from the resistor to the rheostat, and from the rheostat to the switch. So this is the switch, from rheostat to the switch. From the switch to the power supply. I check the connection, switch on the current from power supply, and then I use the switch. Yes, here you can see the ammeter working. So the connection is okay. I move slightly the cursor of rheostat, so the current changes. Why? Because we have inverse relation between the resistance and the current. When the resistance increases, the current decreases, and vice versa. For safety, we do not press the switch on for a long time. Just take the reading and then off. We connect the voltmeter in parallel with the resistor. So we connect the voltmeter in parallel with the resistor. I will use the resistor. Check. Yeah, it's working. Just I replace it because it was in the negative terminal. Yeah. So, but here I connect it to 3 volt. Yeah. Now the voltmeter working, and also the ammeter working in suitable scale. I started to take measurement of voltage according to the table. Each one unit in the voltmeter represents 1 volt. That 1 volt divided into 10 lines, so each line is 0.1 volt. For the ammeter, I use the 500 milliampere. So each 1 unit in that ammeter represents 100 milliampere. I press on. So here it's two dashes, two lines in voltage. So two lines, it is 0.1, 0.2, 0.3. So the voltage is 0.3. And the corresponding current here is, we have to look normally to the ammeter, 65. So it is 65 milliampere. I take another reading of voltmeter, 0.4. So the voltage is 0.4 volt. And the corresponding current here, I have 90 milliampere. So the corresponding is 90 milliampere. 0.5 volt, I have 105. So it's 105 milliampere. Another reading of voltmeter, I include here, it is 0.6 volt. Two lines after, so 20, 25. So 125 milliampere. Okay, 0.7. 0.7 volt, it's 150 milliampere. I take one more reading. It is 0.8 volt, 160. Note that, okay, when the voltage increases, the current also increases. The results on the table, the voltage in volt and the current in milliampere. We plot the graph of voltage on x-axis and the current in y-axis. You can see here, we divide it into 0, 0.1, 0.2. This is the voltage. And the current here up to 160. So we take each unit is 10. For the horizontal line, you can see here 1, 2, 3, 4, 5. So each 5 lines or 5 dashes is 0.1. So one dash or one line is 0.02 on x-axis. We plot the points as you can see. So that are exactly the points. We draw the best fit line. Remember to add the point 0 and 0. When the voltage is 0, the current is 0. It is a straight line passed through the origin, and this is the best fit line. The best fit line, it is a line such that the number of points up equal to down. It is a line path in between the points. We find the slope. How can we find the slope? Draw a big triangle as you can, and then this is y2. You can see here, it's at the middle. So the point of y2, 105. So this is y2. But remember the current in milliampere. So we have to multiply by 10 to the power negative 3. And this is y1, it's 50. Bracket, this is y2 minus y1 in bracket. Multiply 10 power negative 3 because in y-axis, the current in milliampere. So we have to multiply by 10 power negative 3. In x-axis, x2. So this is x2, it is 0.5. And this is x1. Can you see here? x1, it's 2 lines after 0.2. Then x1, its value is 0.2 plus 2 lines multiply 0.02. So it is 0.24. So this is x2. We calculate the slope. The slope is 0.2211. R equals 1 over slope. So this is the calculated value, 4.7 ohm. But the actual value that we used in the experiment was 5 ohm. To compare the actual value to the calculated value, we divide that calculated value divided by the actual value equals 0.9. So we say the calculated value is 0.9 times less than the actual value. What about here the sources of error? We have here in this
experiment, two sources of error. The first one, why our calculated value is not exactly 5 ohm. Number one, the best fit line, because it depends on the drawing. Number two, the parallax error. The parallax error, when we read the ammeter, we have to look directly above the needle of ammeter and the voltmeter. What about the conclusion? We did this experiment to measure the resistance of resistor. We did the experiment and our value was nearer to the actual value. It was 4.7 ohms. I hope you understand this experiment. Thank you.